Good to see everyone again. In this video, we're going to talk about electron capture. This is very unusual compared to what we've seen in previous examples. In this example, we notice that we actually have two substances, two particles on the left-hand side of the arrow and only one on the right. And that's because in this particular example, electron capture, nothing is ejected from the nucleus. In fact, the nucleus takes something from outside and pulls it in. In particular, what we're talking about are inner shell electrons, electrons that spend most of their time very close to a nucleus, sometimes can be captured by that nucleus. And in particular, they're captured by a positive proton. So think about electrons are negative, protons are positive, they are attracted to one another. Sometimes a proton can essentially capture that electron. And when that happens, think about what you're doing. You're essentially neutralizing that proton and electron. And so what we would say is a proton is becoming a neutron by capturing an electron. I look at my example here. We have a parent nucleus of mercury, mercury 197. It has 80 protons. If one of those protons captures an electron, the value of our atomic number is actually going to decrease by 1, while our mass number again stays the same. While we are losing a proton, we're gaining a neutron, and that's why that happens. It's a pretty unusual process. It doesn't happen a whole lot, but it can. So let's take a look at one example and try to practice it. In this example, we have silver 106. Again, for electron capture, we're capturing an electron. So we write that electron on the left-hand side of the equation. And when we do that, our value for our atomic number goes down by 1. That gives us the element palladium. We can get that from the periodic table, and our mass number stays the same. Great. We'll see you in the next video.